or stored procedures or domains or anything like that, because it doesn't really need, again, it doesn't need to know about that to generate the sequence generally. You know, you could call the stored procedure like any other function. All right, yes, question?
Can you do views?
Yeah, views are just treated like tables. So assuming your database driver returns that information, generally the table info method is supposed to also return info on views, and since views have columns just like anything else, from the perspective of Fey, it's the same thing. I mean, it's basically, it's a Fey table object, and the isView attribute is true, but otherwise it's identical.
Can I cache the schema loader?
Yeah, some people have asked about that, and what I've suggested they do is simply load it once and then serialize it to storable, and make that part of your deployment process or something. So there's nothing built in, but it really doesn't need to be. Storable works very well. And in particular, that's an issue for, shocker of all shocks, MySQL. So apparently, I'll just digress a little and bash on MySQL, because God, I hate that piece of shit. Apparently, so MySQL has this problem. Somebody comes into the Fey channel and is like, you know, Fey loader is really slow with MySQL. Really? Well, you know, I have tests for MySQL and it seems to run okay. It's like, it takes a really long time to load the foreign keys. It seems okay. I mean, I make a small test database, but you'd think if it was a real problem, it would show up even then. So what it turns out is, because MySQL was pretty much written by crack-addled monkeys, for some reason, any MySQL developers here? You're willing to admit to it? For some reason, when it's reading the foreign key info from the information schema, this becomes very, very slow if the tables involved have a lot of rows. What? Why does the number of rows in the table matter when you're getting the logical info out of the database? Because it's MySQL and it stinks. Anyway, so yeah, the fix I gave him was do it once at deploy time, serialize it, load it back in. And it's probably a good idea to do it because it's kind of a waste of processing power. I mean, for a smaller app like this, some of the stuff I've been writing, it probably really doesn't matter because it takes, you know, it adds an extra half second to start up on the web app, so who cares? All right, any other questions so far? So, Fey DBI Manager. Basically what this thing is designed to do is to manage a set of one or more DBI handles. I wrote it mostly for the benefit of the ORM, but you could use it independently, although as I mentioned, there is a DivX module on CPAN which does most of the stuff this does, and maybe you just want to use that. One of the nice things it does is it handles forking and threading properly, so it will detect if you make a database handle and then you fork, it'll detect if it's in the child and recreate the database handle properly. Same if you what do you call it? Make a thread. You don't fork off the thread. Spin off the thread and recreate the database handle, which is kind of nice. You can also subclass it so it manages different handles for, say, a master-slave setup. So you could have it say, if the type of query is an insert, update, delete, send it to the master. If it's a select, you could have it do a round robin across the slaves or something like that. It's not terribly sophisticated, and I should point out that if you're doing some sort of more logical partitioning, then it probably isn't the right tool for you because you need to do a deeper introspection on the query. You need to know not only the type of query, but also exactly, like, say, what user ID it's looking at or something like that. But if you're in a situation where you have to do that, then you probably have to write all your tools from scratch for dealing with the database because you're doing something really complicated and custom to your application domain. So these sorts of more generic tools aren't too helpful. So, like I said, I don't think most people look at this, at the DBI manager class itself too closely. It mostly just has a set of sources, and the sources are a little more interesting. So you make a source. And I don't know how many of you are, actually it doesn't really help that much. Forget it. I was going to say something that's not true. Anyway, so you make a source by passing a DSN, username, password. You can also have a post connect hook. I think DBI actually lets you do this internally now, but I think when I wrote this it didn't. So one thing you might do, say, is after you connect, you want to enable UTF-8 Postgres and set the time zone to UTC. And this post-connect hook will be called both when it creates the handle initially, and then if it has to recreate it after a fork or a thread, it'll call it again. So you make sure you always have a consistent set of settings in your database handle. I always do this. I don't know, any of you are in my class, I'll be doing this. I always say what's on the next slide before I go to the slide. So let's get it. All right, so Fey ORM. So Fey ORM builds on top of Fey, uses Fey to generate SQL. You can generate SQL with Fey and kind of integrate it with the ORM. It also uses Fey DBI Manager. It expects your schema class to have a DBI manager. In fact, it sets that up for you and expects you to set a source for your schema class. You'd also probably want to use it with the loader. This is a very SQL-oriented ORM. I feel like, for example, say Divx class is more focused on giving you an OO view of your schema, and I'd say this is more about putting a thin OO veneer on top of your schema, if that makes any sense. It's just kind of a difference in perspective. And like I said, Divx doesn't fit my brain, but I'd certainly strongly encourage everybody to check it out and not, probably not use Fey ORM until they've explored Divx and see if it works for them. In terms of being SQLite, it also lets you think more in sets. You can, for example, do queries that return sets of objects instead of just one object at a time. It's not a dumb object store, so some people who are looking for an ORM are looking for something, say, more like KyokuDB. If you really want something that just lets you serialize your object graph to some sort of anonymous backing store, and you're not really interested in the contents of the backing store except as a set of objects, then Fey ORM is definitely not for you, and probably Divx class isn't really what you're looking for either. You should check out something that's a proper object database like Kyoko. If you haven't heard of Kyoku, it is a object database written on top of Moose that does object graph serialization for work. And so it's a good choice. The other thing with Fey ORM is you'll design your tables first. I think some other ORMs would encourage you maybe more to design your classes first and let your class design kind of guide your schema and database design. Fey ORM, you probably want to do it the other way. It's also Moosey. So, in fact, Fey ORM basically subclasses Moose metaclasses and is a giant, complicated Moose meta extension, which I think is pretty cool. It uses the same kind of declarative syntax that Moose offers, and you can also use any Moose feature in your classes. So you can declare just any sort of attribute, you can use method modifiers, you can use roles, which I find fantastically useful. I'm using them all the time. So it integrates really nicely with Moose. I believe you can use Divx with Moose as well, but it's not quite as well integrated because Divx is not yet based on Moose. I think it will. I've heard rumors that it might be in the future. Again, I can't really speak to what their development plan is. All right, so here's how you use it. So we're going to first you make your schema class, and you have a package, you use Fey ORM schema, it sets up all the meta class magic in the background, just like for those of you who are familiar with Moose, when you use Moose, it does a whole bunch of stuff for you. We need to create at least one source, and then we're going to load our schema using Fey loader, and then we just say has schema, and then we add the source to the DBI manager. And that's kind of some boilerplate that you need to do to set up your schema. I should probably make that I should probably come up with a shortcut that does most of this all at once. Anyway. And then where you're going to do most of your work would be in kind of table-based classes. So we're going to say we have one for an album. We'll use Fey ORM table. We get the schema object. Then we say has table, and we get the table album from the schema object. Then we can do something like has one, and so we can say the album has one artist that has many tracks, and this is kind of the shorthand version where we just pass a table, and then behind the scenes, Fey ORM says, okay, are there foreign keys between album and artist? Yes. Okay, if there's only one foreign key, that's all you need, and it'll generate an attribute called artist. It'll figure out the SQL needed to do the join, and then when you call artist on an album object, it does the appropriate select and fetches you an artist object. For tracks, we have something a little more complicated. We're going to pass the table. We're also going to say, since this has many and will return multiple objects, we're going to say what we want it to order it by. We want to order by the track number. And we're going to turn on caching of this data. By default, has many relationships are not cached because the assumption is it could easily change behind your back, but has ones are. But you can turn on or off caching. It also supports inflate and deflate. So you can say, you do that, it's called a transform, so you say transform and then give a column name. And the deflator, that is how you turn it from an object into something the database can handle. So we say, if it's blessed, then I'm going to use datetime format PG to format it and format it for the database, otherwise I'll just pass it through. You want to do this sort of checking if it's blessed, and if the column is nullable, you'd also want to check if it's defined to avoid a warning. And then what inflating does is take a value from the database and turn it into some sort of object for you. So again, we use datetime format PG to get a datetime object. So when you look at the release date of an album object, you'll be getting back the datetime object, not just the Postgres date string. You can also, there's another form of has one and has many where instead of letting Fey ORM figure out what the foreign key is, you can provide some sort of explicit SQL, which basically can let you do sort of fake joins or just more complex joins, like maybe you don't want all of the items from the related table, you want to restrict it with where clause. So again, you specify the table, and this time we're going to do a select. We're going to select all the artists that are on all the tracks on that album, so that's a little more complicated. There's no actual foreign key maybe there's no foreign key between artist and album, but it's based on the track. You also provide a subroutine reference that will provide the bind parameters for the select, and again, you can turn caching on or off. Any questions so far? Yeah.
Caching, when does cache get validated?
This cache is per object.
Perfect. So lifetime of the object.
Yeah, it's the lifetime of the object, and then the object returns an iterator, which also does caching. There's also there's some global object caching, which I'll show in a minute, which has a different scheme. Is there another question? Okay. How much time do I have? How much time do I have? 20 minutes? Anyone know? Oh, okay. All right, I'll try to go a little faster. So here goes the part where I speak too fast for anyone to understand. All right, so you can have these methods called query methods, which basically define a method with a shorthand where we say, okay, we're going to define a track count method, and it's just based on a select. And just like we saw with has many, you provide a subroutine reference that returns the bind parameters. And so in this case, we can assume that the select is something like select count star from track where album ID equals placeholder. So that's a kind of just shorthand for defining these methods, which is something you're going to want to do a fair amount. The way the constructors work is that you can provide any candidate key to the constructor, and it'll do a database lookup for you. That key can be a multi-column key, it doesn't matter. It just kind of iterates through the possible candidate keys and finds one that matches. If it doesn't find any matching row, it simply returns undef, but you can look at the exception that was generated. It's kind of stored as a class method, class attribute. You can also define your own logic for loading one row. So an example would be that if you call new and you give it a username and password, but you're storing hashed passwords in the database, then you want to actually hash it first. So it looks something like this. So we say, we define this method, that's the logic, and we say, okay, if password exists, then I'm going to get the select object, and then I'm going to use that, and I'm going to pass it the username, and then I'm going to pass it the hash